Hi everyone, in this video we will be evaluating functions with compositions. When evaluating a function, we use an input value to find the corresponding output value. A new technique that we should be using is we can store our equation in y1 and use alpha trace to find the corresponding output value. Let's look at an example. We're going to find f of 3 for f of x is equal to 3x cubed plus 5. So right now, grab your graphing calculator and go to y equals and put 3x cubed plus 5 in y1. I'm going to then exit out by hitting second mode, bringing me back to my main screen. Now what I'm going to do is I'm going to hit alpha trace y1. So this tells your calculator that I'm taking y1, which we put the function 3x cubed plus 5 in. I'm going to open up parentheses and put 3 in parentheses. So we are evaluating the function when x is equal to 3 and hit enter. We're going to get 86. So that's a new technique for us to use. It's going to be helpful when quickly evaluating functions. So y1, 3, and we get 86. So all you have to do is make sure you have your function in y1, and then you can evaluate at any x value. Next, we're going to look at composition of functions. Sometimes in math, we plug a value for x into a function and then use the output answer to plug into another function. When we plug an output y of one function back into a function, this is called a composite function. There are two ways that we can write the composite function. The first way is this. The second way is this way. This is how we read these expressions. F of g of x. What is important to note is when working with the composite functions, we start on the inside. If given f of g of x, we're going to evaluate g of x first. Then the answer from g of x, we're going to plug into f of x. So whatever's on the inside first is what we're going to find first and plug that output value as my new input value into f of x. Let's take a look at some examples. Example. The table below shows values of f of x at selected values of x. The function g of x is shown in the graph below, and let h be the function defined by h of x is equal to 2 absolute value of x minus 4. So the first question is, we want to find each of the following. So first, we just want to find h of 15. So what I'm going to do here is I'm going to use my calculator, and I'm going to put 2 absolute value of x minus 4 in for y1. So 2, go to the math, put a num, hit abs, and that's going to be x minus 4. So I'm going to use the technique that I just taught you with the alpha trace. So I have h of x in my y1, so 2 absolute value of x minus 4. I'm going to exit out, go back to the main screen. Now I'm going to hit alpha trace. Oops, that's not correct. Let me get out of this again. I'm going to do alpha trace y1, open up parentheses, and I'm evaluating at 15. Hit enter. And I get 22. Next, I'm going to look at B, h of f of 2. So this is a composition. So remember, I do the inside first. So I'm going to look at what f of 2 is. So my f of x function is the table. F of 2 is 5. So my output value now becomes the input value. Now I'm going to find h of 5. I'm going to go back to my calculator. Because I have it stored in y1, I'm going to do alpha trace again, y1, open up parentheses, put a 5. And I'm going to get 2. Next, I'm going to do g of f of negative 2. So inside first, I'm going to do f of negative 2. So f of negative 2 is 5. That output value becomes my input value for the function g of x. I'm going to now look at the graph. And when x is equal to 5, 1, 2, 3, 4, 5, my y value is 1, 2, 3. Try the next questions on your own. Thanks for watching.